Welcome back, Hononegah Geometry. This is section 1.2. We're going to start with a little bit of warm-up problems, giving you a little bit of algebra here. 2a squared minus 7a minus 15. Here's how I teach my kids when I try to factors. I always look at the first term and come up with two numbers that will multiply to be 2a squared. So 2a times a. And then I have to, there's where it comes in a little bit of difficulty. Now I got to come up with two numbers that will get me 15, but then I also got to try to get me negative 7. So negative 5 and a positive 3 definitely gets you negative 15, but you got to check the inner positive 3a and the outer negative 10a that has to add up to the middle. So that's called guess and check. Again, there's other ways of doing factoring. So whichever method you need is what you should use. The next one, GCF. So I can take an x away from both, and then what's left inside the parentheses is after you take away that x. And then the last one, how do you solve problems that have been factored? Well, once you have it in factored form, now it's a matter of setting the parentheses equal to 0. And so I get x equals 2 for the first parenthesis, and I get x equals 4 for the second. All right, another review problem from section 1.1. Two other names for AB. So I'm looking at the picture, and anytime I'm asking you for a line or a segment, you can always rewrite the same line or the same segment by switching the two letters. So line AB is the same as line BA. And I also see that there's a cursive letter next to the line, so that would be line H. Name a point not on plane F. So plane F is the piece of paper. We talked about this in section 1.1. So I want a point that is not on plane F, and so that would be point C. Point C is off the plane. Name a pair of opposite rays. The best way to do this one is the up and down one. So we have ray BC going up, and then we have ray BD going down. Then it says name a point not on plane A, B, C. So in the picture, you'll notice ABC isn't really a plane. It's this one going up and down here. And so the point that's not on that would be point E. So again, these are review questions from section 1.1. All right, so now let's talk about section 1.2. Section 1.2 is all about measurements of segments. So some of this is going to seem to be pretty basic, but obviously we can make these problems a little bit more complicated when we start testing your algebra skills. Terms. If you have something that is a postulate is a rule. It's accepted. You don't question it. It's a postulate. It's a rule. It goes without saying. If you have a theorem, now that is a rule that you actually could prove. It's still a rule. You can still assume for it to be true, but you can actually go about and prove a theorem. So this one's a postulate. Points on a line can be matched by 1 to 1, in which the real numbers correspond to a point on the coordinate, a point is a coordinate of the point. Distance between A and B can be written as AB. Notice that there's nothing on top of it. It's just AB. Is the absolute value of the difference. That's going to make more sense if you start thinking about a number line. So I'm going to draw myself a number line down here. And I'm going to put 2 points. So this is the point. Let's say this is 0. This is 1, 2, 3, 4, 5, 6. And I'm going to put a point at 1. And I'm going to put a point at 6. How far is it from 1 to 6? Well, I calculate that distance by finding the difference between the two. Now, some of you might say, well, you can just count this. This would make sense to just say 1, 2, 3, 4, 5. And I wouldn't disagree. But the technical, it'd be 1 minus 6 in the absolute value, or 6 minus 1 in the absolute value. And so the answer to this question is always the same. The answer is 5. The distance between the point 1 and the point 6 would be 5. Now, naming points. We've done this before, but naming points would be point A, point B. The coordinate of the point would be the number. So like the coordinate of the point would be 0 and 6. A lot of times when we're doing these, you'll see these little tick marks, and I'm going to use the red like they do right here, the tick mark that goes down the middle. That anytime you use a tick mark, that means that those two are congruent segments. Their lengths are equal. So notice equal and congruent. These are two different. Okay? AB is congruent to CD. The congruent symbol looks like an equal sign with a squiggly over the top, where the equal symbol is just the equal symbol. The red tick marks over here, the red tick marks over there, mean that those two segments are congruent. So when you're looking at a picture and see those congruent marks, make sure you understand that their lengths are equal and that the segments are congruent. All right, so now comparing segments for congruency. This is plotting points. So I'm going to plot the point -3, +4, and I'm going to label it J. I'm going to plot the point 2, 4, and I'm going to label it K. L is 1, 3. I'm going to change colors here, see if that works. And 1, -2. So I have two segments here. We have the segment LM, and we have the segment JK. Then determine if JK and LM are congruent. So basically, I want to know the distance between those two. So 1, 2, 3, 4, 5. Red has a distance of 5, going from -3 to +2. Purple, 1, 2, 3, 4, 5, also has a distance of 5. So yes, because they have the same lengths, JK is congruent to LM. You try. So go ahead and hit the pause button, and you try this. All right, welcome back. I'm going to finish this question now. -2, +4. +3, +4. So the distance between those two, sorry, my pen went there a little haywire, would be from A to B is 4. Now from C, 0, 2, 0, 2, 0, -2. Give me one quick second here. I'm going to clean this up. So the distance between C and D is also 4. So would you say that AB is congruent? I'm sorry, the distance from A to B is not 4. I apologize. Those of you that might have figured that out. 5. So would AB is not congruent or not equal to CD? So that'd be the answer to be no on that one. Using segment addition postulate. All right, when you have 3 points that are collinear, you can say that one point is between. So notice this picture right here. B is between A and C. So when you say the word between, you are saying that the points are collinear. So notice that E is not collinear. It's not between. This may seem like the most basic type of question here. Postulate 1, 2, segment addition postulate, basically states if I have a segment with a point in between, if I add the two smaller segments up, it will equal the larger segment. So segment AB plus segment BC adds up to segment AC. So if B is between A and C, take the two smaller segments, add them together, and equal the larger segment. And we're going to have a ton of homework problems on this. Begin by writing the equation using segment addition postulate. So DF, here's what I would say. DE plus EF has to equal DF. Notice the two smaller ones have to equal the larger one. And so now just putting the numbers in, you're talking about 23 plus 35 has to equal DF. I don't know that one yet. So when I add those two together, 58 is the measure of DF. So writing this out as an equation, here's how I usually write this as an equation. I do 21 plus x, because I don't know this one yet, equals the entire one of 36. Now some of your teachers might say FG plus GH equals FH, which would then lead you into this equation, because you don't know GH. Solve this. Now using your algebra skills, you're going to subtract 21. So I subtract 21, and I get 15. So GH equals 15. Point S is between R and T. Draw the picture. So here's a segment. Here's R, here's T. Put point S somewhere in the middle. Now, you are given RS, 3x minus 16. You're given ST, 4x minus 8. And then you're given RT is 60. Write an equation using what you know. So if I take RS and I take ST, it's going to equal RT. And now it's just algebra 1. Add the like terms together. Add 24. Again, this is algebra 1. And I get 84. Divide by 7. X equals 12. I apologize. Let's see the, yep. X equals 12. That doesn't tell me anything. It just tells me what X equals. What I want to know is, if X is 12, how much is RS? So 3 times 12 minus 16. RS equals 20. What's ST? 4 times 12 is 48. Minus 8 equals 40. Which would make sense because RT is 60. So if RS is 20, ST is 40, RT is 60. Homework assignment. Well, talk to your teacher about what the assignment will be. Otherwise, it will probably be worksheet 1.2. I wish you all the best. If you have any questions, make sure you talk to your teacher.